Hi, welcome to our DC-SCM 1.0 update. I'm Nathan Faulkner from Google, and I'm joined here by Priya Raghu from Microsoft, and we're just going to go over DC-SCM 1.0 and what's new. So I thought I'd give a little context as to what DC-SCM is, just in case you don't know. There's this whole initiative around modularizing different aspects of platforms. Servers. So here's some of the verbiage that is used in this so-called DC stack. DC-SCM is the security and control module. So you can see this has the BMC, the root of trust. So security and management is what the DC-SCM does. You'll see that the HPM, that would be like your compute, it would be like a motherboard with CPUs, GPUs, one socket, two socket, etc. And you can see that all the security control sidebands connect from the security module, SCM, to the HPM. And this is via a connector called DC-SCI, which Priya will go into more later. So here's just kind of a little background. So why do we want to do this? Why do we want to modularize the security and management? The first point is by moving the BMC and the management and security stuff over to its own module, that makes the baseboard, the HPM, simpler. So just by decoupling those two, you get a quicker development time with the HPM, faster validation. There's an exploding matrix of platforms in the industry within data centers. With the standardized pinout, you can drive toward a common control and security paradigm among all these different diverse platforms. And finally, decoupling the BMC and the security development cycle from the HPM allows you to innovate more. So you're no longer beholden to the HPM itself, its development cycle. If you want to change the BMC part, you do that on your own, on your SCM module, and the motherboard or HPM has its own development cadence. So Priya, can you kind of go back over DC-SCM and what it is?
Sure, Nathan. Thank you for the great intro. So for a quick recap on the DC-SCM, like Nathan mentioned, it refers to the Data Center-Ready Secure Control Module. And at a high level, it modularizes the management and security functionality. It is intended to be CPU vendor as well as BMC vendor agnostic. It is also intended to be scalable across multiple sockets as well as GPU and AI-based systems. So the spec defines a standardized connector interface over a 4C plus industry standard 4C plus connector. And the spec also defines standard form factors, being the vertical form factor as well as the horizontal form factor. And it also attempts to make it future-proof via this serial GPIO interface defined through the DC-SCI. And on the left side, we show the top-level block diagram with some major interfaces through the DC-SCI, as well as some of the major components on the DC-SCM. Okay. So what's new since OCP 2020? So since the last summit, we released the DC-SCM spec to revision 1.0. The link is here in the slide. We did receive some great feedback from the OCP community. So thank you for the feedback. We iterated based on their feedback, and we did deliver some changes. We added 2 additional I2C buses, as well as we added a Gen 5x4 interface on the DC-SCI for future expansion.
And so now we get to show you that we did it. We built DC-SCM modules. So on the left is Google's vertical form factor. We've done multiple iterations of this module. From the picture, interesting things on the picture to note, you'll notice that the motherboard doesn't extend all the way to the front panel. So one of the promises of DC-SCM is that the more expensive material and higher layer count of the baseboard that isn't required all the way to the front panel. Now we have this lower layer count, cheaper, less expensive material on the SCM module that extends to the front panel. And on the right, Priya?
So over the right, we have the horizontal form factor module, which we've been using at Microsoft. So it's a 120.4 mm by 90 mm module, and the connector is a 4C plus connector, the same connector used on the OCP NIC 3.0. However, it is mechanically as well as electrically incompatible with OCP NIC. So it is coplanar and plugged onto the HPM via a straddle mount connector. And you also see the various front accessible ports on the Microsoft DC-SCM here to the right, as well as some front visible LEDs. And you can see some major components on our DC-SCM here as well. Okay.
Great. So what's worked well? Like I mentioned, it has enabled us to move some of the circuitry from more expensive PCBs to less expensive PCBs, just kind of moving that stuff over. It's decoupled, as promised, as one of the motivations. It's decoupled the BMC and root of trust development cycle from the server, which has been very helpful. So you know, I want to try a different BMC part. I don't have to spin a new motherboard. I spin a new security module. And we have line of sight on having this a common SCM across multiple diverse platforms, and we think this is going to save time and validation time, design time and validation time in the long run. Anything you want to add to that, Priya?
No, I think they're all great points, Nathan, especially the decoupling of BMC and the management and security, enabling us to innovate at a different pace from the main HPM itself. That's a great point, as well as building lesser expensive HPMs because we can reduce the overall size of the more expensive PCB material, which more and more HPMs require now as well. So yeah,
Right.
All great points.
What didn't work well? What were the challenges, Priya?
So some of the challenges we faced are, the pinout and the form factor does cover a very vast majority of use cases for at least for us. And we have had some corner cases, some very small number of corner cases where the pinout may not have been sufficient. And for most cases, we've been able to work around those corner cases. But yes, there have been some challenges there for a small number of cases. And DC-SCM does require some upfront work, both in hardware as well as in the firmware, specifically the BMC firmware, as well as the CPLD firmware, to ensure that we maintain a common DC-SCM across several of our architectures. So plug and program does involve some work. And the serial GPIO implementation also has required some work to ensure that we have a standard serial GPIO mapping and CPLD implementation to work across different architectures. Okay.
So looking ahead from Google, we see we're using DC-SCM 1.0. We like it. We're using it on multiple server programs, and we will continue to into the future. We're looking forward to DC-SCM 2.0, and we'll transition to that when it is available and able to support our designs.
Okay, so at Microsoft as well, OCP 1.0 spec has been widely adopted in our current generation of products in development, and we expect to continue that in the future with adoption at least for a minimum of 3 to 4 generations looking ahead. And we are also involved in the 2.0 definition at OCP, and we are actively evaluating it for our future designs. Okay, moving ahead, so please download the DC-SCM 1.0 spec from the OCP website. The link is provided here in the slide. And we encourage you to take advantage of it in your new designs and provide us feedback. And the DC-SCM 2.0 spec is currently at revision 0.7. and please provide your feedback, and so we can make it better for our future products. And you can find more information about 2.0 at this link. Please do stay tuned for DC MHS as well as the DC stack, which plan to be built around DC-SCM 2.0. And you're welcome to get involved by subscribing here to the mailing list provided in this slide. Okay.
Great. Thank you.
Thank you.
I look forward to seeing all of you at the OCP Summit.
Bye.
Bye.